Welcome back to our biomass class, where we're delving deeper into the fascinating world of conversion of biomass resources into heat and power. This video was made with the support of Energy. Biomass is expected to play an important role in the coming future in the transition to a low-carbon economy. The pathway to convert biomass feedstock into heat and electricity covers a wide range of technologies. The previous lesson covers the description of the development status of the technology. For simplification, we considered only 3 levels for technology development. Let us now analyze the recommendations of the International Energy Agency and other organizations for the development of new products and technologies.
There are many publications and a lot of information about what role biomass should play in the future. We have selected for you some clear guidelines. Development of advanced biofuels. Development of torrefaction, pyrolysis, and gasification processes at commercial scale. Development of high-efficiency bioelectricity. Development of innovative biorefinery concepts. Adapt carbon capture systems to biomass systems. Develop advanced biofuels, with improved efficiency of conversion and lower costs. They are also referred to as second or third generation biofuels. They are based on non-food crop feedstocks. Their main advantages are not competing directly with food and feed crops for agricultural land, or cause adverse sustainability impacts. Being capable of delivering significant life cycle greenhouse gas emissions savings compared to fossil fuel alternatives. Related technologies include lignocellulosic ethanol, hydrotreated vegetable oil produced fully from waste and residue feedstocks, biomass to liquid, and biofuels produced from innovative feedstocks such as algae. The next recommendation is to develop torrefaction, pyrolysis, and gasification processes at commercial scale. This includes pre-treatment process to reduce ash content and produce higher quality fuel through pyrolysis, and torrefaction with associated washing of the torrefied material. Pyrolysis oil, also referred to as bio-oil, has about twice the energy density of wood pellets, making it viable for long-distance transport. Biomass gasification should also be considered as one of the technology choices for converting distributed and low-value lignocellulosic biomass to gaseous fuel for generating heat and electricity or cogeneration. After feedstocks and products. The International Energy Agency focus on improved processes. The first recommendation is to develop high-efficiency bioelectricity generation systems. At a large scale, there is potential for high generation efficiencies from BIGCC plants similar to those now being developed principally for use at a large scale for coal. Developing cost-effective designs for such plant at scales matching biomass availability may be challenging. After the improvement of electricity production efficiency, the next recommendation is to create products in an innovative way. To achieve that, the International Energy Agency recommends to develop innovative biorefinery concepts. The biorefinery concept is analogous to the basic concept of conventional oil refineries, to produce a variety of fuels and other products from a certain feedstock. The economic competitiveness of the operation is based on the production of high-value co-products in addition to comparably low-value bioenergy, including biofuels. And finally, the recommendations focus on the reduction of CO2 emissions. Developing optimal configurations to integrate carbon capture systems can be a way to reduce CO2 emissions of biomass combustion systems. So far, carbon capture and storage has mainly been discussed in the context of avoiding CO2 emissions from fossil fuels, but the technology could also be deployed in bioenergy conversion plants. The idea behind bioenergy with CCS that capturing the CO2 emitted and injecting it into a long-term geological storage provides the possibility to remove neutral CO2 from the atmosphere, thus providing negative emissions.
Challenges for CHP systems.
In the field of power generation, it is clear that big plants with more than 50 megawatts show better fuel-to-electricity efficiency than small plants. In the past few years, several electricity-only power plants have been converted from coal to biomass. However, this is not the best solution. Combined heat and power or CHP systems take advantage of increasing the energy efficiency when there is a demand for heat to be covered. Let's focus in small-scale CHP systems that can operate under the concept of distributed power generation, the best solution to produce and consume energy locally. For small-scale CHP systems, the European Technology and Innovation Platform on Renewable Heating and Cooling highlights some challenges. The objective is to achieve systems cost and energy efficient and environmentally friendly. To achieve these objectives, small-scale CHP systems should use of a wider range of biomass feedstock, development of high-temperature and high corrosion-resistant materials, development of efficient storage systems, integration in smart houses and smart grids, and finally, reduction of investment and maintenance costs.
Wrapping up. Recommendations given by the International Energy Agency under a global perspective highlight some key milestones for the next 10 to 20 years. Regarding the challenges for future developments, key issues can be utilization of more diverse feedstocks and development of advanced biofuels. Improve the efficiency and competitiveness of biomass systems, developing new materials and reducing investment and maintenance costs. Integrate biomass systems into smart grids and smart houses.